Good afternoon, class, or good night, good morning, whatever part of the day it is. Today we're going to talk about 6.4 notes, and it is over coordinate proofs. Our goal is to place a figure in a coordinate plane and find the missing coordinates. Seems easy, except for the fact that we are not using numbers. We are using letters. Yeah. All right, so example number 1. We're going to find the coordinates of the unknown point if triangle ABC is congruent to triangle DEC. So why did they tell us these are congruent? Well, they're telling us this is congruent because we can come through and we can mark the congruent parts. Primarily, the horizontal and vertical components are the parts that are really important when we think about what coordinates are missing. So what are we looking for? Well, in this particular problem, we are over here looking for what are the coordinates of point B. So point B means we go to the left. So I know that's going to be negative, and I know that this distance here and this distance here are going to be the same. So if I go this way h units, that means I am going this way h units to get to the line. So this would be negative h. And then I have to figure out how far up I go. So if I look at this point C right here, that is a point 0K. So I went up K to get to that point. And since I also went up K to get to point E, that means that I went up K to get to point B. As you do these, there is no actual like patterns between problems necessarily. You just have to look at the information you're given and make logical, reasonable conclusions. So let's try another one. Equally as fun. All right, so in this particular problem, you are looking for point A, you're looking for the y coordinate of point C, and we're looking for the x coordinate of point D. So why don't you hit pause, take a moment, and analyze this problem and see what you can come up with. All right, my darlings, welcome back. So if I look at this picture, so things I know is I definitely went to the left, and I know that this point right here, oops, I don't know why that's so fat, I went negative to h. So to get to that point C wave at the top, I went negative 2h. I can also use the old triangle congruent properties to determine that these two triangles are congruent. And what does that mean to me? Well, that means to me that this segment here and this segment here are the same length. So if they're the same length and I went over 2h to get to that point right there, basically tells me that every x coordinate on this line is going to be to the left h. So if I want to think about point D, I went to the left h, and because it's on the x-axis, I went up 0. Or I could put that down here. Left h, up 0. So now to get to point A, I've got to think about some other things. So to get to point A, if I look right here, I went 2K to go up here. And because this segment and this segment are congruent, that means I went up 4K to get to this point. So at this point, I can figure out point A. So point A, I went left h, and I went up 4K. And for point C, I already had the left part. I just need to go up 4K because it is on the same horizontal line as point A. Excellent job, my dears. All right, so example 3. Find the coordinates of the unknown point if the figure is a parallelogram. So what does that mean if the figure is a parallelogram? Well, if the figure is a parallelogram, we will eventually learn for sure that this triangle here and this triangle here are congruent. It's almost like we cut the triangle out of a rectangle on the right and slid it over and just reattached it on the left. So that kind of helps me with knowing that this piece here and that this piece here are going to be the same length. So here I went to the left C, or I went C to get to that point, so that distance is C. So when I go to the right, that distance is also C. So if I think about like what this coordinate is here, this coordinate I went over B plus C to get to that coordinate. So when I start thinking of the point up here on the top right, I am going over B plus C. And then when I look at this coordinate, this D tells me that this vertical distance right here is D. So I'm going up D to get to that point. Okay, logical reasoning, look for patterns. Patterns. Okay. Next slide. It says find the coordinates of the unknown point and verify the opposite sides are both parallel and congruent. So again, if I look at my picture, this I went to the left C. So that means that this distance right here is C. If I went all the way this way to A and came back to C, what that's telling me is that this point here is really A minus C. So I went over to A and then I came back C. That's what that point's going to be, and then that would be 0. However, if I went up to this point, that point's going to be A minus C. And then my vertical distance from here to here is going to be B, and that's because of that right here. Then naturally my point here at the origin is 0, 0, so that will help me. Okay, so we want to verify that the opposite sides are both parallel and congruent. So I need two things. For parallel, I need slope, and for congruent, I'm going to need distance. So let's just take the top. So if I take the top segment and I want the slope, I'm going to take the change in y over the change in x. So if I do that and start with the point on the left, my change in y is b minus b, and my change in x is negative c minus a minus c, which is 0 over a, which is 0, which actually makes total sense because this is a horizontal line, and we know that the slope of any horizontal line is 0. If I want the distance formula says we're going to take x2 minus x1 and square it, and then we're going to take y2 minus y1 and we're going to square it. So take a moment, hit pause, and work on the distance of the top piece. All right, welcome back. If you did this and you subtracted your x's would be negative c minus the quantity a minus c, and yes, those parentheses are important. And y minus y would be b minus b. So underneath my square root, I have negative c minus a plus c squared plus 0 squared. If I take a peek here, this negative c and this positive c cancel out, and negative a squared is a squared plus 0, and the square root of a squared is a. All right, so let's now look at the bottom. Okay, so the bottom side of this parallelogram. So the slope is pretty easy because the slope is going to be 0 because my line is horizontal. You could verify that using change in y over change in x. Take a minute, hit pause, find the distance. All right. I know you're back. Some of you never hit pause, you little cheaters. Okay, so the distance is x minus x, so 0 minus a squared plus y minus y squared, which will be 0 minus 0. The square root of negative a squared is a squared, square rooted, which is going to be a. So here's the deal. Parallelograms have opposite sides that are congruent. So if I look right here, I have a side length A and a side length A. They are also parallel, so the fact I have a slope of 0 here and a slope of 0 here verifies that that is a parallelogram. I know how much fun the distance formula is, but I promise the more you practice, the better you get and the easier it is. If you do not know where to start, Number one, write the formula. And you should have this formula about 20 different places in your composition book. Plus it's on the internet, plus it's in your textbook. All right, example 5. Example 5, we're finding the coordinates of the missing points. And they tell you that FB, segment BD, and segment FD are all mid-segments. The good news for that is they've already marked those on my picture. Woo! All right, so if we think about what's going on here, sometimes I think it helps to make like rectangles out of this. So like I can come in here in the middle and that kind of helps. And then here we have this segment and this segment that also come down. So things that would probably be helpful here is knowing that this distance from here to here is H. And knowing that this distance from here to here is 2K. So if you're all the way up here at the top, okay, so this is 2K and this is H right here. That should honestly help us find most of these. So mid segments intersect at the, drumroll please, midpoint. Okay, so remember, midpoints are important. So if we look at my picture, I'm going to take point D first. Point D, how far am I going to go over? Well, I'm going all the way over to this line, which we've already determined is H units. I am not going up 2K, but this segment is K and this segment is K, so I am going up K. If I come over here to F, so point F, I'm not going all the way to H, I'm going halfway to H. And then I decided that this was K units up right here. So because this is in the middle, this is going to be half of K. You could also come over here and write this fraction. Point F is H over 2 and K over 2. That is a different notation with the exact same meaning as point F that I wrote in the purple. Okay, so point B up here at the top. So point B is on the same vertical line as point F. So this is going to be H over 2. And then how far up am I going? Well, this distance is half a K, and this distance is half a K. So I'm really going up K plus another half of K. Need a little more room, so I'm going to come out here to the side, and I'm going to finish this. So if I take K plus half a K, you can think of that a lot of different ways. If we found a common denominator, 2K plus 1K is 3K over 2. Some of you will write 1.5K. That's not great math. It's technically correct, so I would accept it. Some of you would write 1.5 times K. Those are all good. This is probably the preferred method. Some of you might write the 3/2 and put the K out to the side, but please know they all mean the exact same thing. So for point B, the final answer would look something like this. It's H over 2, and then we have K plus 1/2 K, which is 3K over 2. All right, last up, we have a quick linear equation review because these are going to pop up in a future assignment, and I want to make sure that we have put some thought into them. So it says write a linear equation in slope-intercept form through the points -6, 8, and through the point 3, 12. I'm going to give you some hints, and then I want you to work these problems on your own. Refer back to your notes if you need to, and refer to the internet. We've already taught this and gone over this, so this is review. First thing you need to do is find the slope. And then if you think about what we have a point and we have a slope, so you need to use point-slope form. Once we have point-slope form, you can solve for y, and you can find the equation of the line in slope-intercept form. Equation B. Write a linear equation through the point, so here we have a point, 5, 7, and perpendicular to this line. So what we have to remember is if we have the slope of a perpendicular, we're going to take the opposite reciprocal. So this becomes 4/3. So the slope of my new line is positive 4/3. So now I have a point and I have the slope. So I can use point slope form. And really in this one, once I get it into point slope form, I'm done because it just says a linear equation, so any form works. Tomorrow when you come to class, in order to earn your note stamps, you absolutely must have these two problems done. So take a while. Some of you, these will be pretty easy, and some of you are going to have to refer back to your notes. Have a wonderful evening, and I look forward to seeing you guys tomorrow. Bye-bye.